Hey guys, want to know something crazy?
Yes. Yeah.
Even though the moon is thousands of kilometers away from us, it's still an incredibly important part of everyday life.
But how does it influence us when it's so far away?
Well, there's actually a lot of ways that the moon shapes the world around us. From geography to the rotation of the Earth to the way the oceans work. The moon has several different ways that it affects us.
The oceans are a massive part of the Earth too, taking more than 70% of its overall mass. And the moon influences them mainly in the form of tides.
But what are tides exactly? Why are they so important? And where do the strongest tides happen?
Well, let's answer all those questions today. I'm Callum.
I'm Caleb.
And I'm Kinaan.
Welcome to another episode of the Stonehouse Hypothesis. Today, we'll hit you with a wave of knowledge about the tides.
Firstly, let's go back to the moon. It's common knowledge that the moon is constantly orbiting the Earth, which affects several different things on our planet. Along with the wind and the rotation of the Earth, the moon's orbit causes the tides.
But what exactly are the tides? Well, they can be simply thought of as the rise and fall of the overall height of the oceans, caused by the moon's, and also the sun's, gravitational pull as it orbits the Earth.
This is obviously an exaggerated image, and definitely not to scale. But basically, this is what happens with the oceans as the moon orbits the Earth. Now, of course, the tides happen a lot faster. The true motion of the tides is more of a sloshing of water from one side of the Earth to the other.
Cool, so we can basically think of the Earth as a big, round container, and the oceans are sloshing around?
Pretty much, yeah. But how often do these tidal motions happen?
Well, this tidal cycle typically happens either once a day or twice in a day. The highest and lowest points that the tides reach are known as high and low tide, respectively, and the difference between these points is known as the tidal range.
Alright, I think I get it. So it makes sense that there are different heights of tides all over the world. In most places, things don't tend to get too crazy, with the tidal range covering only about a meter.
Yeah, exactly. As you can see in this video here, there are various different heights and depths that the tides can reach all over the world. The gold represents the low tides, whereas the blue represents the high tides. It's really cool to watch too.
Yeah, okay, that's pretty cool, but why aren't the tides the same height everywhere?
Yeah, aren't there places where the tide is higher than it would be or something?
Well, that's just it. There are places where the tides get a lot higher. You can see that there are places where the tide is a lot higher or lower, where the extreme blues and golds show up. But there's one particular place that we should look at, the Bay of Fundy, in between Nova Scotia and New Brunswick, Canada.
I also read somewhere that there's a difference of 50 meters, and if I remember correctly, that's about like 50 to 52 feet.
Yeah.
Yeah, in the water level between the low and high tide.
Even though this is a time lapse, that's still so fast.
Damn, yeah, that is really cool. It moves so quickly, that's incredible. But why are the tides so high? What is it that actually gets them to that height? Because there has to be something else going on, right?
There are a couple reasons actually, but I really want to start with my favorite, which is the resonance that exists in the Bay of Fundy because of like its specific physical characteristics.
Sure.
Actually, it's probably better if we cut to a demonstration right now.
So what do you mean by resonance? How exactly is there resonance in the ocean?
Well, you see, we'll get to that. First, just want to go over the appearance of our mysterious bowl.
Sure.
So, you know that a basin is basically a bowl-like shape that's just filled with water, right?
Yeah,
So
of
we
course.
have here, right here, is we have our bowl, that's our basin, and it's filled with water. So this entire thing altogether is our Bay of Fundy, right? Great way to visualize?
Yeah, that works.
Cool. So we also know that water is a fluid, right? So it always tries to adjust and fill into the container that it's in, so it's always level.
I follow.
Cool. So if we come in and look at our bowl right here, as we move back and forth, that right there is the natural oscillation of the water in the Bay of Fundy. And as I move this entire bowl back and forth, that's the movement of the tides.
Sure.
Alright.
Yeah.
So now if we bring that all together, in the Bay of Fundy, we see that the water itself oscillates at like between 12 and 13 hours.
Right, yeah.
The tides themselves oscillate at 12 hours and 26 minutes.
Approximately, yeah.
So if we look at that and we see we have, as it oscillates, the water oscillates back and forth like that in the Bay of Fundy, and we see that our bowl is oscillating in time, we see that it gets more extreme, it goes everywhere.
It gets pretty extreme, yeah.
And that right there is the resonance that we experience in the Bay of Fundy, and it's one of the coolest reasons for the water level to be so insane.
Right, cool. So, that makes sense.
So the shape of the bay causes the water to move back and forth, funneling the ocean inland. Like a harmonic oscillator, the ocean bounces off of the shores of New Brunswick and Nova Scotia, all the while being funneled up the length of the bay. Eventually, at high tide, the ocean reaches a height of 15 meters. Whereas at its lowest point, the ocean reaches just a mere 3.5 meters.
Another reason why the tides are so high is because of the shape of the floor of the bay itself. Essentially, the bay is shaped like a very gradual ramp and is pitched at the perfect angle to offer some impressively high tides.
Besides this, the Bay of Fundy's high tides have some very interesting applications with biology and energy generation, but that might be a topic for another video.
Well, that sounds like a great idea, Kay.
I definitely didn't know tides could be this cool. I hope you all learned something too.
Yeah, well, thanks so much for watching. Tune in next time to the Stonehouse Hypothesis, where we'll be talking more about the Bay of Fundy and how it's an amazing source of clean power, as well as a treasure trove of ecology. But in the meantime, consider checking out some of the other awesome videos on the University of Guelph Physics YouTube page. I'm sure you'll find something that'll tide you over. Until next time.